Hello, welcome to the video. We'll be looking at section 3.5, last section of chapter 3, and we're going to be looking at equations of parallel and perpendicular lines. So, one of the essential question that we're looking at is how can you write an equation of a line that is parallel or perpendicular to a line um, given a line and passes through a given point? Some of this should be review. Um, Everything is going to be dictated as long as it's written in slope-intercept form, y equals mx plus b. Everything is going to be defined by what the slope is. All right, so if the two separate equations, and if we can say that the slopes are going to be equal to each other, we can say that those two lines, and as long as the y-intercept is different, we can say that those two lines are going to be parallel. Okay? If we can say that the slope of one is the opposite reciprocal, which means like we flip the fraction, change the sign of the other one, then it's going to be perpendicular. So we have to look at that, keep that in mind when we are looking at being able to write equations of parallel and perpendicular lines given a line and it's passing through a given point. And we'll show you examples on how to do that. First off, before we get into parallel and perpendicular lines, one of the questions that they're going to be asking us is they want us to find a coordinate, in this case point P, along the direct line segment AB so that the ratio of AP to PB is 3 to 2. Okay, so basically what they're saying is point P is going to be somewhere on this line somewhere. All right, I don't know where. But what they're telling us is that the ratio from A, well, I'll put back up the point. I'm not saying it's going to be here. AP to PB is 3 to 2. So if you notice here, we have 3, we have 2. What you can kind of get an idea is this is sort of like a fraction. And I want to use the fraction of A to P, and that fraction is going to be 3 of 5. So it's like 3/5 because AP is 3/5 of the value from AB. So with that being said, how we find that coordinate of point P is this. First thing we're going to do is we're going to find the slope of AB. And if you don't remember the slope formula, y2 minus y1 over x2 minus x1. All right, so like this is your x1, this is your y1, x2, y2. Okay, plug that into the formula. So it's going to be 8 minus 2 over 6 minus 3. So 8 minus 2 is 6, and 6 minus 3 is 3. Now, 6 minus 3, I understand is 2, but do not simplify it, all right? Do not simplify it in this case because we need these values here in order to help us find that the x and y coordinate of point P, okay? So what we are going to do is if you realize that this is your, these comes from your y coordinate, these comes from your x coordinate. So to find the x coordinate of point P, what we're going to do is you're going to take the result of the difference, which in this case was 3, and we're going to multiply it by this fraction right here, 3/5. So 3/5 as a decimal is 0.6. So I'm going to say 3 times 0.6, which equals 1.8. To help us find this y point for point P, we're going to take the value of the difference of the y values, which was 6, and this gets multiplied by 3/5, which was 0.6, and that gets us 3.6. So now what we're going to do is I am going to pick this point here to help us find. So I know it's going to be larger in value than 3 comma 2 because it goes upwards. So I know I'm going to be adding values to it. So to find point P, what it's going to be is, since A was 3, it's going to be 3 plus 1.8 comma 2, which was the point here, plus 3.6. So my point P is going to be located at 4.8 comma 5.6. And that is point P with the ratio of 3 to 2. So 4.8 is really close to 5. So I'll say it's like right here. And 5.6. So say it's like somewhere right around here. So this is where point P is going to be. Okay. We'll do one more. So I'll do one that's a little bit different because this one here, number 2, comes out as 3 to 7. All right. Number 1 is very similar to the example we did because this number here is larger than that number, and we just run it as 4/5. Okay. For number 2, we have it as 3 to 10. Now what we're going to do is think about it like this. 3 to 10 means is that it's going to be written as 3 over 10 because you add up the two values together to make your denominator. So first thing we got to do is find the slope. So I find the slope here, and it's going to be, say, 5 minus 1 over 4 minus a negative 2, and that gets us 4 over 6. So again, don't put in Lowest terms. We need those values to help us find our x and y coordinates. So to help us find that x point, we are going to take 4, no, we're going to take 6, I'm sorry, and we're going to multiply it by 3 over 10, which is 0.3, and that gets us a result of 1.8. To help us find that y point, we're going to use 4 and multiply that by 0.3, and that gets us 1.2. To find point P, we're going to take this point here, negative 2, and add it to 1.8, comma 1, and add that to 1.2. So point P is going to be a negative 0.2, comma 2.2. And what I'll do is this. For number 1, point P is going to be 6.6, comma 3.8. So if you're looking at doing that yourself, that's the answer. If you're having trouble, again, leave a comment and I can more than happy to show you the process of solving that one. So again, getting into slopes of parallel and perpendicular lines, like I said in at the first one, for lines to be parallel, slopes must be equal. And when it comes to perpendicular lines, they have to be opposite reciprocals. Another way of looking at it is if you took the slope of one and multiplied it by the slope of another, and if you get a result of -1, then they happen to be perpendicular slopes. So in this diagram, we have 4 lines. So we got line A, line B, line C, and line D, all right? So what they're asking us is to find the slopes of each of these lines, and then we can determine if these lines are parallel and or perpendicular. So looking at line A, looks like it goes up 1, to the right 3, 1, 2, 3. So 1/3 is a slope of line A. Looking at B, I go up 1, to the right 2, so 1/2. C, I go up 1, to the right 2, so 1/2. So I already know that line B and line C are parallel because they're the same. And line D looks like it goes down 2, 1, 2 to the right 1. So it looks like it's -2/1. So parallel lines, I can say that it's lines B and line C are parallel. For perpendicular lines, if you notice, if I took -2 and I multiplied it by 1/2, my result's going to be -1. So I could say that line D is parallel to line C and line D, not parallel, perpendicular to line B. So line D is perpendicular to line C, and line D is also perpendicular to line B. Here they're asking us to write an equation of a line that passes through the given point, -1, 1, and is parallel to the line y equals 2x minus 3. Anytime they give you a line, we want to make sure that we can identify the slope, all right? So since it is in fact in slope-intercept form, I can identify the slope. The slope in this case is 2. So since the slope is 2, that means that the equation of our new line must be a slope of 2 as well. So my new slope is going to have to be 2. And since they give us a point, you can do this one of two ways. You can use slope-intercept form to solve it, or since I know the slope, I know the point, I can use point-slope form, which is y minus y1 equals m times by the quantity of x minus x1, where this is my x1, this is my y1. So to plug it in, I can say that this is y minus 1 is equal to m, which is 2, times it by the quantity of x minus a -1, which is essentially x plus 1. Distributing the 2, so I get y minus 1 is equal to 2x plus 2. Add 1 to both sides, I get y equals 2x plus 3. And this particular line is parallel to this line. And if I plugged in -1 in for x, I would get 1 as a result for y. So it does cross through that point. Looking at this one here, same idea, but now we're looking at perpendicular lines. So what first we have to do is, this is not in slope-intercept form. So I got to put it into this form. So that means I got to get y by itself. So now I'm going to say that this is y going to be equal to -2x plus 2. All right, so now that I have it in slope-intercept form, the slope of this is -2. In order for it to be perpendicular, my slope for my new line has to be the opposite reciprocal. So I flip this fraction, it's going to be 1/2, and since my original slope is negative, my new slope must be positive. So my new slope that I'm going to use is +1/2. I know it crosses at this point 2 comma 3, so I'm going to say y minus 3, which is y1, equals my slope, which is +1/2, times by the quantity of x minus 2. Go about distributing the 1/2. Y minus 3 is equal to 1/2 x minus 1. And then I can add 3 to both sides here. Y equals 1/2 x plus 2. So number 4 is, again, very similar to what we looked at in the previous questions. If you do have additional questions with number 4 and would like to see it solved, please leave a comment. I'm more than happy to look at it. But I'm going to look at number 5 here. It says, how do you know that lines x equals 4 and y equals 2 are perpendicular? So what we have to keep in mind is, when you just have a single variable and a constant that's equal to a constant, it's either going to be vertical or a horizontal line. Okay, anytime it's x equals, this is my vertical line, and this is my horizontal line when it's y equals. So if I were to look at this in a graph, x equals 4, so I'm going to go 1, 2, 3, 4. Vertical line goes up and down. So here is my vertical line. My horizontal is 2, 1, 2. And I draw it in like so. And these are, in fact, perpendicular lines, okay? Because if you look at with respect to the slope, a horizontal line has a slope of 0, okay? And a vertical line has a slope that is undefined. The reason why it's undefined is because you have some number and it's divided by 0. So if I flip that, it would be 0. So that is why they are in fact perpendicular. Okay, so last thing that we're going to look at here is says they want us to find the distance from 1 comma 0 to the line y equals negative x plus 3. All right, anytime we talked about this in a previous lesson, that the distance must be perpendicular from the point to the line. So essentially we're trying to find the distance from 1 comma 0 to 2 comma 1. So since I know that it's because my slope is one up 1 to the right 1, that's a slope of 1. It is the opposite reciprocal to negative 1 in this case. So I can use the distance formula to help me find that distance. So I can say that this is going to be the square root of, we'll say x2 is 2 minus x1, which is 1, square that, plus 1 minus 0 quantity squared. 2 minus 1 is 1. 1 squared is 1. 1 minus 1, 1 minus 0 is 1. Square that is also 1. So I got 1 plus 1. So I got square root of 2. And the square root of 2 is about 1.41. So that would be the distance from 1 comma 0 to the line y equals negative x plus 3. And that is being able to look at equations of parallel and perpendicular lines. Hope this helps. Until next time.